So continuing our work with graphing linear equations using a table, I want to talk to you about two special cases, two special lines that I want you to become very familiar with so that you just know them by memory, okay? These are the vertical lines and the horizontal lines. Now the vertical lines, they have a very special kind of equation. You're going to recognize them because the equations of every vertical line can be written as x equals a number. And what you're going to notice is that we will not have a y variable. There's no y variable in the equation of a vertical line. So when you have an equation that says x equals a number, so let's say x equals 2 or x equals 1, that will be an example of a vertical line, and the graph will be a line that goes straight up and down like this. But because of that, then that line's going to intersect the x-axis, but it's not going to have a y-intersect. Vertical line's going to have an x-intercept, but it's not going to have a y-intercept. Okay, we'll talk about what the x-intercept is when we go look at our examples. The horizontal line now, these equations look like y equals a number. Y equals a number, no x variable this time in the equation. So those lines are going to go left to right. They're going to go straight across left to right. And those lines are going to be parallel to the x-axis. So they will not intercept the x-axis. So there will not be an x-intercept. And then we'll talk about the y-intercept. Let's go look at a couple of examples of these special lines. Okay, so look at this example. Example number 4 says negative 5x equals negative 30. Do you notice that we have no y variable in this equation? Yeah, so this is an example of a vertical line. And I'm going to just show you negative 5x equals negative 30. The first thing I want to do is divide both sides by this negative 5 because I want to put this equation in that form that says x equals a number. It happens to be that x equals 6. Do you see that? Now, if I was going to make a table of values like we did in the last video, for this line, remember how we can always choose x? But this time we cannot choose x because the equation is telling us something about x. What does the equation say? It says x is 6. That's the only value x can be. So every single order pair that's on this vertical line has an x value of 6. I'm going to write 3 down because remember how we're using 3 order pairs to graph the equations? All 3 order pairs have to have an x of 6. The equation is forcing me. Now, here's the other thing. Y, that y variable, it is not on that equation, right? So what that tells me is that y does not depend on x. Okay, x being our input variable, but this time around with the equation, there are no restrictions on y. Do you see that? There's no information about y. That means y can be anything. So you pick your favorite 3 numbers for y. I'm going to pick negative 3, 0, and 5. Okay, so there was nothing said about y, so we can pick any 3 numbers. Let's graph these now, these order pairs. So 6, these are each 1, x and y. 1, 2, 3, 4, 5, 6. So here's 6, okay? So 6, negative 3 is here. 6, 0 is here. And 6, 5 is up here. Notice how they line up one on top of the other, vertical, just the way we expected it, right? We expected that. And so when we join these 3, then we get this nice vertical line. And notice, what's the x-intercept? This point where the vertical line crosses the x-axis. Yep, if you said 6, 0, 6, 0, you were right. So this is 6, 0. But then what about the y-intercept? Where does the line cross the y-axis? It does not. You're absolutely right. So guess what? We write does not exist. We write DNE or does not exist, does not cross or none. Okay? There is no y-intercept. This line has no y-intercept. Okay, so did you catch that? So it's up to you to recognize that anytime that you have an equation, x equals a number, that is a vertical line. And you have to keep track of all these properties for the vertical line. Let's take a look at 5, number 5. Okay, so now look at number 5 here. And do you notice that this time we have no x variable? No x variable in the equation. So let's solve for y. Let's add 9. So we get y equals negative 3. Okay, so there's our equation. I'm going to make a table. Okay, I get to choose any x. Any x. Oh, let's go. Let's choose -3, 0, and 2. Now, what's y? When x is -3, what is y? Well, when you go up to the equation is telling us that y is -3. So I'm going to put -3. When x is 0, what's y? Well, the equation says y is -3. Okay. When x is 2, what's y? Well, the equation says y is -3. Y will always be -3, no matter what x is. Y is not dependent on x. Do you see that? Okay, so let's go ahead and graph these. 0, -3 is here, -3, -3 is here, and 2, -3. And so notice that we do get that nice horizontal line that we talked about. Oh, sorry about my horizontal line being a little off there. But we get a horizontal line, y equals a number, horizontal line. It has a y-intercept, doesn't it? Right here. It crosses the y-axis at the point 0, -3. But what about the x-axis? Right, none. None. Does not exist. There is no x-intercept for this vertical line.